So, here we are on linear equations still, and we're looking at another type of form of equation that we can use to represent a linear function. And it's called point-slope form. And it's really quite straightforward, because all we need to do point-slope form is a point and the slope. So, let's look at this. We can use any point that we have, and we're going to call that x sub 1, y sub 1. It is the one point that we have that we know is on the line. The only other thing we need is the slope. And we can work out the slope either with, doing our rise over run or using our slope formula. And that will be enough. If you have one point and you have the slope, you can make sure you move up to the next point or down to the next point. We're used to having slope-intercept form, and slope-intercept form is when you have the slope and the y-intercept. But we're going to pretend we don't have the y-intercept, we just have one point and the slope, and we're going to use this new form that we're going to look at. And point-slope form is this: y minus y sub 1. Y stays as y, it doesn't get turned into a different number. The y sub 1 is where we're going to plug in the y value from our ordered pair. So y minus y sub 1 equals m, the slope, multiplied with the quantity of x minus x sub 1. So our point that we're going to use is the x sub 1, y sub 1. That's going to plug into here. And the slope that we know is going to plug into m. And then we leave it looking just like this. So, as a matter of interest, it is the slope formula rearranged. If it looks a little familiar to you, recall this is the slope formula. M is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. That gives the slope between the 2 points. If you multiply both sides by the quantity x sub 2 minus x sub 1, you'll get something that looks very like that. Just the subscripts are different. But that's where it came from. So let's try and pull some information out. I've given 3 examples in point-slope form. Let's make sure we can identify what the point values are and what the slope is. And I'll just notice again, we're going to find the x here following subtraction. If it doesn't follow subtraction, you've got to think about what that means, what the x value was. We're going to find the y value here, again following subtraction. And if it's not subtraction, think about what that means. So, y minus 5. Following subtraction, the y value is 5. 2 is the slope. 4 follows subtraction, so it must have been the x sub 1. So there we have it. The point was 4, 5 and the slope was 2. In this next one, the 5 is following addition. So if it had started life as y minus something, wouldn't it have to have been minus 5? So our y value is minus 5. Our slope is negative 6. And our x value, our x sub 1, is 7, following subtraction, so it is what it is. And the last one. The y value, y sub 1, is 2. Our slope is 1/2. And here the 6 is following addition, so that means it must have come from the fact we were subtracting a negative 6. So the x value is negative 6. So straightforward pulling information out of point-slope form. And on the next board, we'll see how straightforward it is putting into point-slope form. Except that I think we need this one here. So, don't let me forget to get to that slide there. So, here we have y minus y sub 1 equals m times quantity of x minus x sub 1, point-slope form. Putting in information. I have a slope of negative 2 and a point of 4, 1. And I need just to place it into our form. And you can see I've set up kind of the skeleton part of point-slope form here just for speed as we go through this. Y minus 1 equals slope of negative 2 multiplied with quantity x minus 4. And for the time being, you don't have to distribute anything, you don't have to rearrange, we just leave it literally in point-slope form. So this is quite straightforward, isn't it? Here we have y minus 2 equals slope of 3 multiplied with quantity x. Because if this is negative, I'm going to turn this into add 5 because we were taking away a negative. And the last one, y, because we're taking away negative 8, we'll change this to y plus 8 equals the slope of 1/2 multiplied with x minus 6. And there we go, plugging information in. So what do we have to be careful with? You have to be careful, because the x is the first value you see in an ordered pair, don't put it in where the y sub 1 needs to go, because that would be a mistake, wouldn't it? And also, if you are subtracting a negative, make sure you put it, turn it into addition. So we're going to get rid of that one, and then we're going to put back up the one that I actually wanted next, third. There we go. More often than not, you might want to turn your point-slope form into slope-intercept form. It's usually like a stepping stone to get to slope-intercept form. If you don't have the y-intercept but you have some other point, you're going to use point-slope form and then convert it into slope-intercept form. That's what I've often used it for. So, how to go from point-slope to slope-intercept. Here's a reminder of what point-slope is, and here's a reminder of what our slope-intercept is. So here we've got it in point-slope form. So what did I do? I distributed the 3. So that would be your first thing to do. So you want to distribute. And then what do we do from this line here? I just rearranged. I just solved for y. Added 6 to both sides. So very straightforward, going from point slope, distribute, rearrange, and you've got slope-intercept form. And over here, I'm sure we did the same thing. Here we've got something in point-slope form. We distributed, and we rearranged, and we've got it in slope-intercept. So very convenient to plug in information and rearrange to get slope-intercept form. And the only other thing I need to show you is, if I give you 2 points, can you put it into slope-intercept form? So here we've got 2 points, and we're going to find the slope first. We're going to use the slope and one of the points to put it in point-slope form, and then we're just going to convert it to slope-intercept form. So if I need to find the slope between these two, I've got 8 minus 4 over 3 minus 1, so that's 4 over 2. So we've got a slope of 2. So I'm going to set up my point-slope form. You only need 1 point, and it doesn't matter which point you use out of the 2 that you've got. So I'm just going to use, maybe I'll use this one, looks kind of straightforward. So y minus 4 equals slope of 2 multiplied with quantity x minus 1. So just plugging it in. So using the technique we had up here, we're just going to distribute and rearrange. So we will have y minus 4 equals 2x minus 2. Add 4 to both sides, giving us y equals 2x plus 2. There we go. So 2 points, not a problem. And before we used point-slope form, we wouldn't have been able to get into slope-intercept form. And this one, let's just do this one. So we want to find the slope first. 8 plus 1 over negative 2 take away 4. We got 9 over negative 6 equals a negative 3 2ths, negative 3 halves. Let's just make sure we think we divide out 3, yep. So then we're going to plug it into point-slope form. Shame I picked a negative fraction, but there you go. So y, which one should I pick? It doesn't matter, I think I'm going to go with this first one. Y plus 1 is equal to negative 3 over 2, the slope, multiplied with x minus 4. So we're just going to be careful when we distribute by a negative, and then we're going to rearrange to do what we need to do. Y plus 1 equals negative 3 over 2x, and that's going to be plus, so that's 12 over 2, 6. And then I'm going to subtract 1 from both sides, write it small here. Y equals negative 3 over 2x plus 5. Sorry, it's a bit cramped there. Hope I didn't make any mistakes as I was going through that. So, really not too bad, and a really nice handy stepping stone to use to get into slope-intercept form. And the last one. When might we use this? Well, I've got a couple things that I'm going to show you. Let's say we've got kind of part of a data table. We don't have it when x is 0, we've just got some kind of random numbers, and we want to find the slope-intercept form equation. I know we could kind of work backwards to get to when x is 0, but let's pretend we can't for some reason. So we need to pick 2 points and find the slope. They don't maybe look like points, but we could pick any points we wanted. We could pick this as an ordered pair and this as an ordered pair, couldn't we? And we're just going to find the slope between those 2 points. So we want to find, let's do 1725 minus 1275. Goodness, why did I do this to myself? So I think that's 450 over a difference of 2. So the slope is 225. So in the context of our story, that's going to mean that every line in a newspaper ad is going to cost me $2.25. Point slope form, we're going to plug it into y minus, it won't matter which one we use, let's just use the first one so I remember, minus 12.75 is equal to 2.25 multiplied with x minus, which point was I using? This one here, 3. I'm not going to do the math out actually because I'm running out of room and I don't really want to multiply by decimal at the moment. But you can see how you can just with one next move or 2 next moves get into slope-intercept form. And that is plucking 2 points out of a data table. And here we've got a geometry application. A right triangle has the points A, B and C. Write the equation for the hypotenuse. So if we kind of draw a sketch of a right triangle, we want this one here. And we want to make sure between which 2 letters are we actually going to find the hypotenuse is the first thing. Well, they're going to be 2 points that have absolutely nothing in common. These 2 will have an x in common, these 2 will have a y in common, so we need 2 points that have nothing in common, which would be A and B. They've got no x's or y's in common, so they must be the ones on the ends of the hypotenuse. So we will find the slope first of all. So we will do -2 minus 7, I went in this direction, -3 minus 5, so that's -9 over -8. Goodness me, what was I thinking? So this would simplify to 9 over 8 as a slope, and then we're going to plug that in. Y minus, I'll just pick the first point, 7 is equal to the 9/8 slope multiplied with x minus 5. And then we would continue, multiply through by the 9/8, and that would be 45 over 8, and then I would add 7 to both sides. And we would have it in slope-intercept form. So there we have it. Not too much to think about for point slope form, but very handy kind of intermediate step often. Be careful of making sure you plug in your x and your y into the right position, and if you have to change any signs. And that's it.